हाँ, मैं अभी एक एक्सपेरिमेंट और करता हूँ। हाँ हाँ, तो आज शाम को कंप्लीट करके फोन करता हूँ। पर आप तो करोगे ना? रात को तो नहीं करना ना? ठीक है ठीक है। हाँ, मैंने ऑन करा था। Yeah, so I think we can start now. So once again, good evening all. Myself Rituraj Singh Rawat. I am currently working as a Prime Minister Research Fellow in Department of Earthquake Engineering, IIT Roorkee. This is a particular NPTEL course. Name is Geotechnical Engineering 2 Foundation Engineering, having a code NOC 26C50. This course is currently being tutored by Professor Dilip Kumar Bedia, who is Professor in Department of Civil Engineering from IIT Kharagpur. So those who are joining this session for the first time, let me tell you what are the objective of these sessions are. So these particular sessions are meant to interact with our learners. We'll be discussing some of the important concepts which are required to solve the assignment problems. Along with that, we'll be solving some of the sample questions which will be helpful for you to solve that particular week's assignment questions. Along with that, we'll be also solving some of the doubts of you concerning with the course. And apart from that, if you are having any non-technical query, let's say if you want to discuss some issues related to your career related guidance, or apart from that any guidance which I can help you with, feel free to discuss with us. So let's start with our sample questions today. So this is the first question for you. The first question which is there in front of you is how the over consolidation ratio is defined is.
Sir, is the answer C? Is past effective stress to the current? I think so.
Yeah, so let's check this. Yeah, so the answer is C. So over consolidation ratio we generally define as like how much the particular element of that soil has experienced the past stress, and what is the current effective stress which it is facing right. So usually it basically defines means how much soil is uh, tolerable to carry a certain amount of load. So usually it depends on how much stress it has experienced in its past. So to account for that particular phenomena, we usually use a certain parameter which is known as the over consolidation ratio. So it is basically the ratio of the past maximum vertical effective stress to the current vertical effective stress. Yeah, so the answer is correct. It's C, the ratio of the past maximum vertical effective stress to the current vertical effective stress. Yeah, so now in question number 2, you need to select a correct statement about the pre-consolidation pressure in context of the soil mechanics.
Sir, B answer, I think.
Yes, Sudhanshu,
Yes, sir.
you were saying something?
Yes, sir. I think B answer is, I think, correct answer. Maximum
Okay.
effective stress experience
So let
in
me
the
read the
past.
question. We are talking about the pre-consolidation pressure. Mm, pre-consolidation pressure. Yeah, so I think it's a B only. So it is related to the first question only. So the particular stress which the soil has experienced in its past uh, is known as the pre-consolidation pressure, and it basically signifies the maximum effective stress that a soil has experienced in the past. So yeah, the correct answer is B.
सर लास्ट मतलब थर्ड वीक का ऐसे ही हुआ था या नहीं हुआ था? Uh,
थर्ड वीक का एक्चुअली आई वाज ट्राइंग टू कंडक्ट द सेशन, बट प्रॉब्लम ये हुआ था कि देयर वाज सम नेटवर्क इशू फ्रॉम माय एंड, and I couldn't able to inform the NPTEL team, and that's why they couldn't able to notify you people. But I have recorded a lecture from my end. You can get the link of that YouTube video uh, on the same sheet which has been shared to you by the NPTEL team.
okay.
So you can get both that NPTEL video as well as the sheet.
Okay.
Yes.
Okay.
Yeah.
No
I'm
problem.
so sorry for that. But if you are having any doubt in that week sample question, please feel free to discuss. We can take that things into account.
Oh, okay, sir.
Yes. So any doubt in this question number two? If not so, then let's move to question number three. Yeah, it's a numerical based question. So you have been asked like there is a top surface of 8.2-meter thick saturated clay layer which need to be instantaneously covered with a 3.4-meter thick layer of fill material. The gamma bulk is given to you. If the clay has a coefficient of volume compressibility of 5.51 into 10 to the power minus 4 meter square per kilonewton and a saturated unit weight of gamma set of 19.6 kilonewton per meter cube, the consolidation settlement of the clay layer due to the placing of fill material is. So you need to calculate the consolidation settlement of the clay layer due to the placing of fill material. So you can solve this and ping your answer in the chat box. Within 5 minutes, we will discuss this. Yes, guys. So let's check the answer. Do you have any answer from your end? Okay, then let's check this. Yeah, so the correct answer is 317.3. So you have been asked, like, there is a 8.2 meter thick saturated clay layer, and it has to be instantaneously covered with a 3.4 meter thick layer of fill materials. So this is your fill material. So the gamma bulk of fill material is 22.1 kilonewton per meter cube, while the clay layer is having gamma. I think we don't require this. Then also we can write this. So the coefficient of the volume compressibility for this is mb is equals to 5.51 into 10 to the power minus 4 meter square per kilonewton, and gamma sat value will come out as the 19.6 kilonewton per meter cube, right? So this is a fill material property, this is the thick saturated clay layer property, mb and gamma sat, right? So we need to evaluate the consolidation settlement of the clay layer. So consolidation settlement of the clay layer is basically given by an expression which is your mv, change in your effective stress delta sigma dash, and what is your initial height of your thick saturated clay layer. So usually mv, if we see in our case for the clay soil, is 5.51 to 10 to the power minus 4 meter square per kilonewton. And if you see the change in the effective stress, so delta sigma dash. So as we can see, since we has placed this fill material over the thick saturated clay layer, so whatever surcharge which is coming is due to this fill material surcharge. So it is having gamma is equals to 22.1 kilonewton per meter, right? So if I see this 22.1, and what is the height of this layer is 3.4, right? And what is the initial height of the layer, soil layer, which we are taking into account, which is it is a 8.2 meter. So it is 8.2. So the consolidation settlement can be obtained it as 5.51 into 22.1 into 3.4 into 8.2, right? So it is asking in the mm. So the value which I'm getting here is 3394 into 10 to the power minus 4 meter. So if I see this thing in mm, 39.4 into 10 to the power minus 3 meter, which is your none other than 339.4 m. Yeah, so I think we don't have any value corresponding to this. We can go with the closest answer which is available to this, and it is option C. So yeah, the correct answer is option C. So this is the particular expression which you need to take into account for the calculation of the uh, so- calculation for the settlement of the soil layer due to consolidation, which is MB delta sigma dash into H. Okay, so this is question number 3. Let's move to question number 4. Any doubt in this, guys? Not so, then let's move to question number 4. In question number 4, you have been given that the pressure transmitted by a 3 meter by 3 meter size square footing on a cohesive soil with E as 5.24 into 10 to the power minus 10 to the power 4 kilometer per meter square with a mu value of 0.38 is 168 kilopascal. Considering the foundation to be a rigid foundation with IF value of 1.12, you need to evaluate what is the immediate settlement of the footing. So you are having a 3 meter by 3 meter size square footing, having with the cohesive soil, elastic modulus is given to you, mu value is given to you. Assuming that the foundation to be a rigid foundation with IF value of 1.12, you need to calculate what is the immediate settlement of the footing.
Sir, I think answer is not there. I think
What you're
like
getting? 10.2?
10.3, sir. I think because it's closer to 9.2, so I
Okay,
think it is 10.2.
okay, then let's check since we don't have any other learner here. As expected. 1 second, please. Yeah, so we need to evaluate the immediate settlement. So let's check this. The immediate settlement of the footing, as we know, is given by your Q into B into what is
B
that? Mu square
mu square
into IF upon
I upon E.
E, right? So
Yes.
what is the Q value you have upon?
Sir, Q value is I'm getting is 168.
Yeah, it's given in the question, right? The
No,
pressure
yep.
transmitted by the footing. The
Pressure
height of
on
footing is 3 meter.
B meter. 1 minus mu is 0.8556. Maybe I'm directly calculating it.
Yeah,
1 minus.
100.38 square. And IF value is also given to you, right? It's
Yes.
1.12.
1.12 upon 5.24 into 10 raised.
5.24 to 10 raised to power 4 kilopascal, right?
Yes, sir.
So how much this value is coming out as?
Sir, basically it's coming out for 82.94 upon 2 52400 into 1.12. So
Acha, let me check
only
my
upper value if we calculate, and afterwards it's coming to be at 0.01032.
yeah, so I am getting it as 9.21 into 10 raised to power minus 4 on 9 into minus 3
162, 168.
meter. So which can be assumed as the 9.21 meter.
Oh, sir,
And
I think calculator error, so I don't
no
get that.
worries, no worries, no.
Okay, something adding value that way.
Yeah. So the correct answer is 9.2 mm. So option B is correct. So it's straightforward. Like you just need you have an expression for the calculation of the immediate settlement. You can take that thing into.
Okay.
So is it all right? Any doubt in this?
No, sir.
Okay, okay, Sudhanshu, no worries. So let's move to question number 5 then. Yeah. So
Yeah.
you have been given with an average void ratio of a 6.5 meter thick layer of normally considered layer is 1.5, and it has a coefficient of the consolidation of 3 meters square per year and a compression index of 0.46. If the effective overburden pressure is equivalent to the increase in the vertical pressure caused by the foundation load of the clay layer, the change in thickness of the clay layer is. So you have been given with a certain description of a soil layer which is having a void ratio of 1.05, and the thickness is given to you which is 6.5 meter. The coefficient of the consolidation is 3 meters square per year, and the compressive index which is given to you is 0.46. You have been given with the effective overburden pressure which is equivalent to the increase in the vertical pressure caused by the foundation load on the clay layer. Yeah, then you need to calculate the change in the thickness of the clay.
Sir, can you please install it? I've like overburden pressure and it's equal, I think, delta.
Hmm.
So we have to take it equal 1 1, I think. So it can give value of 2.
Yeah. So the log 2 value you want?
Uh, is it right, sir? I take a 1 plus 1 upon uh,
Yeah.
1.
So in the question, it has been given to you that the effective overburden pressure is equivalent to the increase in the vertical pressure. So your increment and your initial effective pressure are same. Yeah. So usually the formula which is given to you is Cc into H upon 1 plus E naught log upon sigma naught plus delta sigma upon sigma naught, right? So since sigma naught and delta sigma are equal, so yeah, within the logarithmic you'll be having the 2 by 1. So log 2. Yeah. That's what you were asking, right?
Yes, sir. I was asking like first pressure is I've been taking 1 and another pressure is I taking 2. So 2 by 1 is answer. So log 2 will be
Yes, yes, yes.
getting.
So that was it. You
So I
can
have to take a 2 directly,
yeah, you
or
can
not
take
2 by 1.
yeah,
Oh,
so that was the trick part in the question. So you can take the 2
oh,
directly.
okay, sir. Is answer D, sir? I think.
Yeah. So let's check. Yeah. So the answer is coming out as a D. So let's have a look on this. Yeah. So the question number 5 is there in front of you again. Let's have a check on this. Yes, so the correct answer is option D, 439. So the average void ratio is given to you is E naught is equals to 6.5 meter. Sorry, that is the thickness layer. E naught is given to you is 1.05. Coefficient of the consolidation is given to you Cc equals to c meter square per year. Compressor index, okay, it is a Cv which is given to you. Then Cc is given to you as 0.46, right? So let's calculate this. So your settlement uh, is given by settlement due to consolidation is given as CCH 1 plus E naught log initial sigma with your increment in your stress with your initial sigma node. So Cc, which is given to you as 0.46, and the height of the layer is given to you as 6.5. 1 plus E naught is 1.05, and log, it is given to you as sigma naught is equals to delta sigma. So your sigma naught plus sigma naught upon sigma naught, so this will come out as a 0.46 into 6.5, 1 plus 1.05 into log 2. So let's check the answer. Yeah, so this is coming out as 0.439 meter, which is your equivalent to the 439. Yeah, so the correct answer is option D, 439. So I think, any doubt in this? Okay, then let's move to question number 6. So now you need to calculate the total consolidation settlement in centimeter of the clay stratum. The properties of the clay stratum is given to you. It is having a thickness of 6.1 meter. Natural void ratio is given to you 0.962. The final void ratio is given to you, which is 0.654. So what is the total consolidation factor? Yes, of it.
Actually, I'm taking the money, but I need to convert to India rupee.
अच्छा.
So you need dollars? Already you need dollars.
No, anyway, I'm like I don't need dollars.
So I give you in rupees.
Yeah, you give me nine. So
Uh,
it would take time. See, how much need 3 4 days it will take.
Here in
SBI, I guess.
civil line, I can meet
Western Union.
Ah.
Those
So
people.
he will call me, then I will send you.
Acha, you are having dollars.
Yeah, so he's not in this office right now.
Acha, acha. Usually he closes his
So
office at
evening, like after dinner maybe.
Okay, okay, no worries. Oh, चला. हाँ यार वो क्लास लेनी है तो वो चला रहा.
ले रहे हो क्या?
हाँ अभी क्वेश्चन दे रखा बच्चों को फोन कर रहा है. ठीक है भाई ठीक है. हाँ 2 3 आए तो चले गए.
एक ही बच्चा है बस.
एक ही है भाई, बीच में आते रहते जाते रहते. हाँ
ओह,
लेना पड़ता है पर एक बच्चे के लिए. हो गया.
कल कल ही.
ठीक है. ओह
मजा आ रहा है ये भाई घूमने का.
तो नया बड़ी लिया.
ये तो पार्टी वाला ही था.
10th में देखा.
हाँ नया लिया इसी साल. वो सिद्धार्थ अमन सर जितने आते थे लिया था. उन्होंने लिया मैंने भी लिया.
कितने दिन चलाएगा कोर्स?
कितने खा लिया ये?
मैंने कोर्स कितने
3 दिन. कल खत्म हो गया. भाई कोर्स वाले बंदे परेशान हो गए थे. उनको कहा कि ये करना है, मॉडलिंग ऐसे दबाना है, ऐसे दबा के जाना है. ये सब एक ही आदमी करता. मैंने 10 लोग करते हैं साल. और उनको तो ये बताया कि तुम्हारा सेकेंडरी काम है, प्राइमरी काम तो कुछ और है. फिर वो बोले कि अच्छा प्राइमरी काम तो तुम तो एक ही हॉस्टल में रहते हो. हाँ रात को काम करते होंगे ना.
बोलते ना कि पैसे कम दे रहे हो.
इनको पता ही नहीं कि इनको पता नहीं कि ये सब तो सेकेंडरी काम करता है पैसे के लिए, प्राइमरी काम तो कुछ और करते हैं. तो जान निकल गई भाई इनकी तो करते करते. पिछली बार यही यार लेक्चर थे, हैंड्स ऑन कम थे. इस बार लेक्चर 3 ही है बस 3 दिन. बाकी पूरा दिन करते रहो
मॉडलिंग करो.
करते रहो.
फिर तो लाइसेंस लिए तुमने मेरा
टेम्परेरी लिए.
टेम्परेरी सर.
टेम्परेरी मतलब उनको मेल करते हैं कि उन्होंने रेलवे उसको बेचा ना एक्चुअली, तो उनके उसमें तो ऑलरेडी इंक्लूडेड होता है. वो जितने लोग चाहिए उनको फायदा ही है. तो हमें मना करते हैं. खराब है ना सॉफ्टवेयर, हमें बोलते हैं कि ठीक करो इसको.
तो तुम्हें फिर इंस्टॉल करा होगा ना कम फर्स्ट.
पिछली बार रखा था चला के हमने वहाँ किया है. सीसी में लैब है. 25 कंप्यूटर हैं.
देखा था तुमने तुम्हारा मतलब कैमरे में फोटो देखा था.
अच्छा हाँ. और सुनाओ.
कुछ नहीं चल रहा.
आ गया आपका वीज़ा? मुझे बताओ क्या क्या डॉक्यूमेंटेशन करनी है, क्या क्या करना है.
कल आ जाएगा.
मेरा इस बार पोस्टर मिला है, पिछला मैंने रिजेक्ट कर दिया था, उन्होंने रिजेक्ट कर दिया. कल मिल जाएगा. ये डॉक्यूमेंट जो रेडी किए थे. हाँ अभी मुझे पता था कल देखना चाहिए.
तुम मेरे से पूछ लेना.
ये है ना.
हाँ
ले लो ये रेडी कर देंगे.
बोनाफाइड बनवा लो.
आईटी का
मतलब बाकी सब तो वो एक दिन का काम है.
बोनाफाइड बनवा दो.
बस बोनाफाइड बनवा दो.
अरे अब इस बार उन्होंने रूम कैंसिल कर दी. मेरा मुझे लगता है मिलेगा कि नहीं.
वापस अप्लाई करो.
बोला था तब हमने कैंसिल कर दिया.
वो कुछ ग्रुप बनाया तुम्हारा यूट्यूब पे होगा, देखा मैंने.
उससे क्या होगा?
नेशनल वाला कुछ पता नहीं.
वो उसने पता किया था. पल्लवी ने बोली कि 1 लाख रुपए का मिला था सिर्फ रूम उसको इलेक्ट्रिसिटी और सब अलग, या कम से कम 1 10 में सब कुछ मिला के मिल रहा था.
हो जाएगा अभी कुछ ना कुछ गया. मैं जाके बताता हूँ. Yeah, so let's check in this. So the answer is coming out to 95.7. What you are getting?
Same, sir.
Same, right? So yeah, there is just a relation between your So let's check answer. It's B. And so there's a direct relation between the settlement and your change in the void ratio. So that is delta H by H equals to your delta E upon 1 plus E naught, right? So in the question you have been asked to calculate the total consolidation settlement. So it's delta H, and your change in void ratio is 0.962 minus 0.654 1 plus E naught. Your initial void ratio which is given to you is 0.962, and then you need to multiply it with what is the initial height of the soil is, which is none other than it's a 6.1 meter. So delta H will come out as 0.962 minus 1654 answer divided by 1 plus 0.962 answer into 6.1, which is your 95.7. So 0.957 meter I am getting. So when it will convert, it's the 95.7 centimeter. So correct answer option is option B. So any doubt in this?
No, sir.
Okay, then let's move to question number 7. So from question number 7 to 9, it's a set of questions. So let's read question first. You have been given with a 3 by 3 meter square footing, which is positioned 3 meter below the ground surface in loose to medium dense sand. It's having a total pressure of 200 kilopascal at the foundation level. The unit weight of soil is 18.5 kg per meter cube. Use the equation ES equals to 2 and meganewton per meter square. So where your N is the SPT number, computing the modulus of the elasticity of the sand, and the depth of the compressible layer is 10 meter. Assume settlement is required at the end of the period of 34 months. You need to use the Sherman-Mann's influence factor method. The SPT test conducted at the site gave the following n values. So you have the SPT conducted at the site will give you the following SPT n value: n equals to 8, n equals to 12, n equals to 18. So influence factor at a depth of the 1.5 meter below the base of the foundation is, yeah. So this is the information which has been given to you. There will be a set of question. First question, you need to evaluate what is the fact at a depth of 1.5 meter below the base of the foundation.
Oh, sir, I don't get it. Can you please explain this?
Yeah, I'll do that. Okay, so let's check this. So what has been asked in the question? You have been asked to calculate the influence factor at a depth of 1.5 meter below the base floor. So the correct answer is B, and let's see how it's coming as second. So if you see the influence factor diagram, so as per Sherman, this is how your influence factor diagram basically looks like. If let's say this is a particular depth which has been given to you, and yeah, this is the diagram. This is the maximum value of the influence factor which occurs at a depth of b by 2, and then it goes
2B.
to b, right?
Yes, sir. For a square footing, or if strip footing, it will be B and 4B, I think.
Yeah,
Sir, I think it's from below that, no? 2B.
to
Like,
b.
should be like 1.5 meter steps because it's 3 by 3. So we have to take it from B by 2 values. से नीचे लेना पड़ेगा, I think.
uh,
Total.
from here you are saying to b, right?
हाँ, I think. Maximum value से नीचे.
Maximum value. So how the Schmidt diagrams for the square footing is given as, like, various sir might have given in the notes, right?
Sir, diagram is I think okay, but the value of 2B is I think starting from maximum value to the 0. Like,
Okay, okay, okay. Let me check once.
okay.
Do you know in which lecture this topic has been covered?
Sir, third lecture.
Lecture
This was
18.
like, I think so. Like
Yeah, I'll
in
check it.
this week's lecture. Sir, take a numerical, but the theory is in before I think 17 lecture.
Okay. So is it visible to you?
Yes, sir.
Yeah. So I think that 2B is considered from the top, like from the base of the footing only, right? So your B by 2 is from your base of the footing, and the 2B is from your further base of the footing. But you are saying it's from here, right?
I think so, sir. Yeah, it might be wrong, sir. I think so. It
The
can.
vertical effective stress at a depth equal to B by 2 from the base of the footing, or from the
Yeah.
surface. Yeah. So I think we need to take this thing into account. No, it will be 2B from the surface.
From surface, it should be 2B, right, sir?
Like from the base of the footing, it will be 2.
Base of the fruit. Sorry.
Yeah. So this will be 2, right? So in the question, what had we asked? We need to calculate the influence factor at a depth of 1.5 meter below the base of the foundation. So
So
1.5 meter. Yeah. So at the 1.5 meter, so B by 2 is your 1.5 meter, right?
yeah, at the max level. Right.
Yeah, at the max level. So basically, they are asking to calculate the influence factor, the maximum influence factor only.
Uh,
If we check this, right? Which slide is shown to you? Okay. So it's IE max a point 0.5. So present something else.
yes, max should be good. Depth to breadth ratio.
So you need to calculate the I epsilon max, which is your none other than 0.5 plus zero point 0.1 Q effective divided by sigma dash B, right? This is the formula. Any doubt in this?
Yes. Yeah, but sir,
Yeah,
uh,
please, please ask.
uh, I'm got confused, sir.
Yeah,
Little bit.
so in this, uh, they are asking to calculate the influence factor at a depth of 1.5 meter below the base of the foundation, right?
Like we have to calculate for maximum value. So we have to take
Yeah,
zero point
actually
0.5 plus.
asking us to calculate the 1 point at 1.5 meter,
Huh,
and at
no, it eventually happened to be a maximum value.
it happens to be maximum value. So that's why
Okay.
we are using this particular relation to
Uh,
take into
relation.
account for the maximum stress factor.
Okay. So I have to use this formula to calculate the maximum
Yeah, yeah,
EI.
yeah, yeah. So in the
Okay.
like since the question I asked for the 1.5 meter, and uh, eventually 1.5 meter comes out as a position for the maximum stress factor. So that's
Okay.
why you need to use this particular relation, like to
Because
calculate
sir,
the.
I thought that we have to take two more points and we have to collaborate medium
No, no, it's fine.
distance.
So, anyways, if it would have been some other position, like we need to do it then accordingly. But I think we can go for maximum relation directly in this case.
Okay.
Okay.
Wait. Yes, sir.
So then
Wait.
let's solve this. So
Zero
in the
Q
question, basically they are asking you to calculate the Q effective.
Q upon V is 2013. Got it. So uh, big factor is cancel. Sir, it is coming 0.86.
0.86.
Yeah.
Let's
So
check the answer.
0.5 plus 0.1 root 2000 because it's Q upon gamma is our 18.5 into depth 3. So uh, rho df, so 3 into 18.5 is 55.5. So 55 root x. 1 minute, sir. 2000 upon 55.5. That will be 0.254 into 0.1 into 0.1. So 0.025 plus 0.5. No, 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 sorry, sir. Sorry, sir. 0.525. It's answer, I think.
I'm
Zero.
having different answer with me. Okay, then let's check. Might be mine one can also be wrong. So how you are calculating the Q effective?
Sir, Q effective is I am taking the row into effective depth. So 3 meter is the effective depth,
Uh,
and Q is our sorry, row is our 18.5. So
mm,
18.5 into 3. So it should be 22 point. Sorry, 55.5. I think so.
yeah, but yeah, you have already been given like a surcharge load also, which is the 200 kPa with the total pressure at the foundation level.
Sir, I thought it is ultimate Q. So I take it upper.
Yeah,
Like
so actually you have been given with the total load which has already been covered coming at the base of the foundation. So to calculate the effective load or effective stress, you need to reduce the uh, surcharge from the total load. That will give you the Q effective. So
okay,
whatever value you have calculated for the overburden. So that value need to be reduced from the total stress. so which is the 200 kPa, which is given
minus
which is given in the
55.5.
yeah
So I have to deduct it like to 2000 minus 55, 55.5.
yeah
So I get the
200 minus 55 point whatever you're getting.
ultimate bearing value.
Yeah.
Okay, so two.
What is the Q effective, by the way? It's QF minus gamma df. Gamma is your
So sir, it 144.5 upon 55.5. I mean in the root. So
yeah in the root.
in in the root 144.5 upon 55.5. 0.216. So
Yeah, so if you
into
solve it with Q, it's I upon epsilon max. So zero point 0.5 plus zero point 0.1. Q effective as given, it's none other than your Q minus
1
gamma df,
df
right? And then
upon
B
gamma df
B is your effective stress at that particular point. So how much is your, so it's none other than your gamma into
df
df plus b by
plus
2, right?
oh, oh 1 minute 1 minute sir. So I have to recheck it.
So
Gamma is 18.5 into df is 3 into 1.5. So it can be changed. So 8.5, 18.5 into 3 into
what
18.5,
is 18.5?
83.25. So 144.5 upon 83, 144.5 upon 83.25. So root answer 1.3. Okay. Okay. So mm, into 0.1 plus 0.5. 0.61, I think. 617.
Let me check. 0.1 plus 0.5. How much you're getting?
0.317. 0.6317.
Yes. So even I am getting this. So 0.6317, and even the answer is 0.62. Yeah. So the correct answer is option B. So it's equivalent to 0.62. So is it clear to you how we are obtaining each parameter in this expression?
Sir, can you please repeat it?
So
Like,
first, it has been asked in the question like you need to evaluate the influence factor at a depth of 1.5 meters, and eventually it came out as a maximum influence factor position. So we can directly use that particular formula which has been given in the question, which is none other than your not in the question, in the lecture, which is 1 epsilon Emax equals to zero point 0.5 plus zero point 0.1 underscore under root q effective by sigma dash mu, and your q effective is none other than your uh, charge minus the gamma df. So at the base of the footing, how much is your effective stresses? So this can be calculated using this formula, right? And then sigma dash b is your the effective stress at that particular position, where we are counting the calculating the influence factor, and in our case it is at the position of the b by 2. So anyways your footing is embedded at the depth of the 3 meter, right? And then further we are calculating at the 1.5 meters, so your gamma into df plus b by 2. So gamma
yes, 0.5.
18.5 into 3 into plus 1.5, and in this case your q is 200 minus gamma 18.5, and depth of the foundation is 3 meter, right? So that's how we are calculating the maximum influence factor. uh,
Okay. Okay.
you can still ask if you are having any doubt in this.
No, no, sir. It's like, sir, it's close to 6.3, so we have to take that, right, sir?
Yeah, yeah. So the answer which we are getting is 0.6317, and it's
Yeah.
closer to 0.62 as given in the option. So we can go for the option B.
Okay.
Okay. So this was the first part of first question of this uh, question set, and then we can move to the next question, which is question number 8. Now it is basically asking you to evaluate the influence factor at a depth of 4 meter below the base of the cave.
So, sir, we have to take two common mean
Yeah,
of both
so
the
now you can interpolate it because when we
interpolate.
know it's linearly varying at 2b, so now they're asking to calculate at the 4 meter.
Okay. Okay.
Okay. The question is visible to you, right?
Yes, sir, but I don't have options for that.
Yeah, in this I haven't given options. Just obtain the answer whatever you're getting. I'll
Oh, okay.
further
Okay, sir.
clarify that. Yeah.
Okay.
Yeah. So shall we check the answer?
Yes, sir. I'm just checking the actual video a little bit so
No
I
worries.
can.
No worries. I'll do this. So let's go with this influence diagram only. So just have some tab I guess. 1 second. Copy. Yeah. So here is your b by 2, and if you see the influence factor values at this point, let's say your b by 2. So here your value is 0.632 and here your value is 0, right? So in the question they are asking us to calculate the 4 meter below the base of the foundation. So 2b means this value means this particular depth is your 6 meter depth, and here is your depth is 1.5 meter depth. So if I check this, So 4 meter below the base of the foundation. So they are asking us to evaluate the 4 meter below the base of the foundation. So this is 1.5 meter. This is your 6 meter, and then there's another line. They're
Four.
asking it's 4 meters. So this is your 4 meter. So from here to here, it will be your 2 meter,
Sir,
right?
I think I got one answer is 0.421.
Okay, you got. Just let's check in this case.
Okay. Okay.
So then we can go with the similar triangle. So since this is your 6 meter, this is 1.5 meter. So this total length will be your 1.5 meter, right? Sorry, 4.5 meter.
4.5. Yes,
So
sir.
if you go with the similar triangle, so let's assume here your influence factor
Right.
value is x, right?
Yes.
So if I
Yes.
go with 2 by x, the similar triangle, and then here you will be having a 4.5 by 0.632, right? So if I
Uh,
evaluate x here,
Sir, I think we have to take x upon 0.63 is equal to 4 upon 4.5 because that will be your, I think,
no,
answer.
so like you need to take into the similar triangle. So in this case, the triangle which I can see is your this triangle,
Oh, okay.
right?
Total triangle.
Yeah, so this is the total triangle I'm taking it of. So if you are
Okay.
having any other method, you can also use this. There's no, it's just a geometry. So
Okay.
4.5, so it's 0.632
Into 2.
into 2 upon 4.5. So it's coming out as
0.28.
0.28.
Okay.
So
Big
the answer which I'm having with me, yeah, it's 0.281 meter only. So
0.28.
the influence factor
Right.
is 0.28.
Take it is 0.4, so I got wrong answer.
Where you have taken the 0.4?
Sir, I had taking four like total length, like
Acha, acha.
4 by
But
x is equal to
you don't
well,
have any triangle here, na? It's basically a
yes.
trapezoid. So
I'm thinking the total triangle is for like 1.5 from 4 meters, so that can change.
no worries, no worries. But now you got that right.
Yeah, yes, sir, yes,
Okay, okay.
absolutely.
Then let's
So
move
that's why
to.
it's got double, sir. So that's why I got 0.42, and it will be 0.2.
Okay, okay, get that. So
Absolutely.
it is coming out as double of this answer. So
Yes, yes, sir.
no worries, no worries. Then let's move to question number 19. So in this question number 19, basically they're asking you to calculate the depth factor C1 of the foundation is.
Sir, we have calculated before that to 2000. So,
Yeah. So how much you are getting?
sir, settlement of ultimate loading should be 2000 minus rho into df, right? 18 into 3.
So we need to calculate C1. So do you know, have you checked what C1 is?
Sir, 1 minus 0.5 qs upon
Q
q
effective, right?
effective. Yeah.
So if I check this, your C1, are the slides visible? No?
No, sir. No, sir.
Okay, okay, sorry.
It should be 0.31, I think.
Your C1 is none other than 1 minus zero point 0.5
5
QS
qs
by Q effective,
q
right?
effective. Yes.
So your QS, if you see, is your effective overburden pressure.
B by 2 is
QS is your surcharge at overburden pressure at that depth, at
B
that
meter.
foundation piece. So that will be your gamma into df, right?
Yeah.
So gamma, which has been given to you, is
18.5.
18.5, and depth of the foundation has been given to you as
3 meter.
3 meter. So it will be 55 point something. How much you are getting?
55.5.
55. And then when we are talking about the Q effective, so that is none other than total pressure. So your Q total minus QS. So your Q total is 200 kPa minus QS is your 55.5. So if I take calculate this, so your
Uh,
200
44 point,
144.5.
144.5. 144.5.
So this is your kPa and this is your kPa. So if I calculate the C1, which is
3.38
1 minus zero point 0.5,
into 0.5.
so it's
So
55.5 upon 144.5.
0.80, sir.
How much you're
7.
getting? Point,
0.8079.
yeah. So I think it is equivalent to 0.81, which is the option
8
B.
only, yeah. B option, sir.
So if you check this, the correct answer is B, option B.
Yeah.
It's clear, right?
Yes, sir. Absolutely.
Okay, okay, Sudhanshu. Then let's move to question number 10. So this question is basically again the calculation of the consolidation, primary consolidation settlement. So the top and the bottom of the normally consolidated clay strata, which measure 8.2 meters in thickness, were permeable layers. The initial overburden pressure in the middle of the clay layer is 308 kPa, while the clay's liquid limit and initial void ratios are 66.66% and 0.79 respectively. Due to the construction of a new building, this pressure increased by 115 kPa. What is the probable primary consolidation settlement of the building is? Perfect.
Sir, presentation
Yeah,
is.
yeah, sir.
Yeah. Sir, option B, I think.
You're getting option B.
Yeah.
Okay, then let's check this. Yeah, it's option B. So how did you do that? So in the question, they are asking us to calculate the probable primary consolidation. This we know the probable primary consolidation is given by CCH1 plus E naught logarithmic to the base 10 sigma naught plus delta sigma upon
Sigma
sigma 0,
0.
right? So have been given with CC?
No, sir, we have to calculate
We have
that.
to
So
calculate, right? So
66,
the Utterbuck limits are given to us. So liquid limit, void ratio was
60
given.
66 minus 10. So it
So CC is your 0.009, 1 minus
1 minus what liquid limit.
liquid limit, right?
Yeah.
So 0.009, 1 minus liquid limit is
So it,
your
56.
uh,
66 minus 10.
66, right? So 0.66, right?
Yeah. So it eventually coming out to be 6. Oh,
So how much it is?
uh,
So 0.504.
3.
Actually, it's liquid limit minus 10. Sorry,
10, sir. Oh, so,
sorry.
yeah,
It's liquid limit minus 10, and you
10
need to put it in the percentage only. So 66 minus 10.
minus 10. So it's 56
It's
into 0.0.
56 into 0.09, which is your
0.504.
0.504. Okay.
Oh,
And the initial void ratio is given to, so
0.79. So
yeah, it's the initial void ratio is given to
E0 is equal to 0.79.
the initial overburden pressure in the middle of the clay. The sigma naught is given to us, right?
Uh,
And then delta sigma is also given to us, is 115
no,
kPa.
no, no, yeah,
Okay, then we can solve it
I
directly.
did 8.2. Yeah. So
So your FC is CC point 504 into H
8.2
8.2
upon 1 plus
E naught.
0.79.
E naught is how much? 0.7679.
0.779, sir. Wide ratio. Okay.
Sigma naught
Now,
is your
sigma is equal to 308 minus
308
115
plus 115 upon sigma naught
upon
is 308,
upon 308. Yeah.
right?
Oh, log 10.
So how
So,
much it is?
so it in meters it's 0.318, and if
0.318
we
meter you're getting.
converted it multiply by 1000, so it will be no sorry in centimeters, so by 100, so 31.8. So yeah,
It's in meter, right? You're getting meter.
meter. meter. Yes, sir.
So 318 mm.
Yes.
Yeah, so the option B is correct. Nice.
Correct.
So the only catch was here is this calculation of the CC value. Okay. So
Yeah.
shall we
Yes, sir.
give some more time? Do we have one more time? I think. Uh, yeah, we can solve one more question and then we can call it a day. Mhm. Yeah, you can solve this question number 14. Okay, then let's see this. Uh, so there are two cases with you. So one, they are talking about 50% consolidation case. And another, they are talking about the 70% degree of consolidation. So when, and basically in one case they have defined like they are having a clay sample which is of 25 mm, and it is at draining at the top only. So at the bottom you don't have drainage, and it's only draining at the from the top part, right? So, and it is having 25 mm. So 50% consolidation occur in 11 minutes. So your 50% consolidation is occurring in the 11 minutes. So we need to take into account the degree of consolidation equation. So we know that the when your u is between 0 to 60 percentage, there you need to calculate the time factor with a formula which is pi by 4 upon u by 100 square, right? Where your u need to be inserted into the percentage. So why we are doing this? Because they have given us like the 50% consolidation occur in the 11 minutes. So we know there's a formula which is known as the time factor is equals to CVT by h square, which is the time required for your drainage. H is your length of the drainage path, CV is your coefficient of the consolidation, and time is your time factor. So we know this, and with the help of this we know this. So we'll get what will be the coefficient of consolidation. So this will be utilized for the calculation for the time required for the clay layer in the 70% consolidation case. So let's calculate this. So pi by 4, u is your 50 and 100 by square. So your t value is none other than 0.784 into 0.5 square. So your t is 0.196.
0.196.
So now calculate your CV. So your 0.196 into your hatch. How much is your drainage path? So it is draining only at the top, so that will take into the whole soil layer depth into consideration. So that is a 25. So CV is equals to T into H square. H square is how much? 0.25. Sorry, 25 mm. So if I take this into meter, yeah. So I think we need to do the conversion also, because CV is 0.196 and your time is given as 11 minutes and your H is 25 mm. No worries, then we can calculate this thing directly in minutes, and then we can convert it into T's. So H square is how much? 25 mm square, and your T is 0.196. Sorry, your small t is 11 minutes. So if I calculate this, how much I am getting? 0.196 into 25 square, answer divided by 11. You will get this thing as the 11.14. Twenty-five is your mm. square per minute. Okay, and now we'll proceed for the 70% consolidation case. So here we have got the CV value 11.14 mm square per minute, and now we'll move for the 70% degree of consolidation case. So here you are having a drainage at top and bottom. So let's say in this case, again the depth is same 25 mm, but your drainage is happening from the top as well as from the bottom. So in this particular relation, since the drainage is happening from both the sides, so your the drainage path length will be 1 by 2 of that drainage length. So here your your u value is greater than 60 percentage. So the time factor which I'll calculate here will be 1.781 minus 0.933 log of 100 minus u percentage. Okay, so it's none other than 1.781 minus 0.933 log of 100 minus u is your 70 percentage. So the time factor will come out as 1.781 minus 0.933 into log of 30, which is your 0.402. So your this will come out as a 0.402.
Sir, why we take 0.933? Wait.
0.933.
Oh,
Actually, this is the time factor formula which has been
oh, okay, okay, okay.
given like in the, I guess, 1 degree consolidation theory, one dimensional consolidation theory, if you will check. Okay, so
Okay.
then again we'll use the same relation T equals to CVT by H square, and here they are asking us to calculate the time required for the clay layer. So here T will be your 0.402 and your H will be basically 1 by 2. So it's 2 meter thick. So here we just need to take the 1. And also since the CE value is mm square per minute, so we'll convert this uh, into mm. So 2 by 2 into 1000. So you got that right, why we have taken 2 by 2, because the drainage is happening from the top as well as from the bottom. So here drainage was happening only at the one end, so we have taken the full uh, depth of the clay layer, but here since drainage is happening from the both end, so we'll take consider only the half thickness. So just take care of this. So 2 by 2 h square h is your how much? 2 meter, and yeah, we need to convert it into mm, so we'll multiply with the 1000 into this, and here t h, and c value already we are having, it's 11.14, so it's 11.14. So if we calculate this, 0.402 into 1000 square, answer divided by 11.14, so I am getting 36086.18 minute. But here in the question they are asking us to calculate in days, so we'll convert this into days. So minutes, so this divided by 60, this divided by 24, so we'll be having 25.05 days. So the correct answer will be option C, since it's more closer among all the four options. So here is the answer, option C, 25 days. So any doubt in this, Sudhanshu, Sumant?
No, sir.
Okay then.
Sir, just I've doubt with that formula. I don't know that.
This
What
time
is-
factor formula.
Oh,
Yeah, so you
uh,
can check in the lecture notes where they might have derived the one-dimensional consolidation theory. So there the formula has been given there, the time factor
okay, sir.
formula.
I will recheck it.
Yeah, you will cross verify. You can cross verify.
Okay.
So if you are having any doubt, we can discuss. Else, let's call it a day. Those who will be watching these videos later at a YouTube channel, you can post your queries in the comment section of this YouTube video. I'll definitely address this, and please try to attend the sessions in live on Tuesdays. So like it will be more helpful for both of us. So yeah, that's it. So thank you so much for the joining. Let's meet on next Tuesday.
Thank you, sir.
Thank you, Sudhanshu. Thank you, Sumant.